Okay, in the RSA method, in order to do encoding and decoding, it's necessary to raise numbers to very large powers. So here we have, for instance, 23 to the 485. Now, 485 is a very large power. Now, in raising 23 to the 485 is a huge number. Now, what makes this result small is we're taking the modulus of this, taking the result mod 617. So the final result is going to be between 1 and 617. Now, this exercise talks about a fast and convenient way of computing such powers given a modulus. And it turns out that you need to use binary expansions to compute large powers mod n. All right. So in this video, I'm going to introduce what is binary expansion and show you how you can compute them automatically using a spreadsheet. Now, before I get into doing that, let me do an example first. A more familiar example is a decimal expansion. For instance, if I have 1984, whoops. Well, let's take a nicer year. Let's take 1776, for instance. 1776, okay? That's equal to 1,000, or 1 times 10 to the third, plus 7 times 10 squared, plus 7 times 10 to the first, plus 6 times 10 to the 0. Okay, so I can say that the 6 is the 1's place, the 7 is the 10's place, the 7 here is the 100's place, and the 1 here is the 1,000's place. Now, you should be familiar with this. So my binary expansion is 1, 7, 7, 6. And in fact, we write numbers in binary expansion. Now, here's a question. How could you get the computer how can you generate automatically the decimal digits? For instance, if I put the number 1776 into a computer, how could I get the computer to spit out the individual digits of the decimal expansion? Right. And this is going to be, like I said, this is going to be useful when we do the corresponding thing for binary expansion. All right, well, let's think about it this way. If I take 1776 and I take the mod base 10, I'll get 6. Now 6 is the 1's place, right? Okay. Now I could certainly include this command in a spreadsheet, and I could get this as the result. So here's a way to automatically get the 1's place for any number. Okay. Now, suppose I do the following. Suppose I take 1776 minus 6. Now, this 6 comes from here, right? And divide it by 10. What do I get? Well, I'll get 1770 over 10 is equal to 177. Okay. Now, notice something here. If I take mod of 177 base 10, that gives me the 7, which is the 10's place. Okay, pretty cool, huh? Now I can take this 7, and do the very same thing again. I can take this 177 that I got and this 7 that I got here, and I can take I can take 177 minus 7 divided by 10. That's going to give me 170 divided by 10, which is 17. And if I take mod 17 base 10, that's going to give me the 7, which is the 100th place. Okay. This may be reminiscent to you of the Euclidean algorithm. This way that we take our result and we go down farther, this kind of iterative method, but there is some difference. Okay, so now what do we do? Follow the same process. I'll take the 17 minus 7 over 10. So that's going to be equal to 10 over 10 is equal to 1. And if I take mod of 110, now that's equal to 1, and that's my thousandths place. Okay, so that has given me all the thousandths place, tens place, hundredths place, tens place, and ones place. This is an automatic way of generating the decimal digits of a number. Okay, let's go over to a spreadsheet and see how this works. All right, so let me put my spreadsheet to the window. Oops, I don't know why it's doing that, but here we go. Okay, so let's start with my original number, and that's 1776, so this is way too small. Let's make things bigger. Now remember, the first step we had was to take the mod of this number, base 10. Okay, so that's my ones place. Okay, what's the next thing we did? Well, we took the number here minus the number here and divided by 10. Well, let me put a parenthesis around it because I'm going to divide everything by 10. And I get 177. Now, the second digit was mod of this result, base 10. That gives me 7. Okay? The next stage of the reduction was the number here minus the last digit divided by 10. And here I took the mod of 17 base 10. Now actually it's the same formula as here. I'm just going to fill it down. Okay, fill down is here. Now at this point, the formula down here, if you can see the formula here is A3 minus B3 over 10. To go to the next row, I'm just going to fill this down. So I can actually fill both of these down. And I'll get my last digit. So here are my decimal digits that correspond to my original number. Now, the way I've done this, you can see that this formula here gets filled down to the next level. It's basically all filled down. And the formulas in the second column also are filled down. Now I can simply replace this number with a number as large as I want. Okay. Now you see it's not quite done. I just continue to fill down. And it will take me to completion. All right, see it gets to zeros when it's in, but you can read off the decimal digits. 7 is the ones digit, 6 is the tens digit, etc. All right, so that's a way to get decimal digits. Now, let me copy this, and I'm going to make a little change here. I'm just going to copy, Let me paste it over here. Okay. All right, it's going that way because it doesn't have enough room. All right. Now, instead of decimal, I'm going to go ahead and do binary. So let me just do it, and I'll explain a little bit more later. Now, binary means what? Here we had a base 10. You see this formula has mod 10. If I replace the 10 with a 2, then that's going to give me binary digits. Okay, and then here I'm going to go down. We'll just continue to fill down. And you can see that, well, I think I actually have to change the formula here as well. You see, this is divided by 10. I'm going to have to divide by 2 instead. Okay, so in this case, I'm going to have a whole number. So what did I do from here to here? All I did was change the 10 in this formula to a 2. And I also changed the 10 in this formula to a 2. And then I filled both down. Let's see what happens when I fill this one down. All right, you can see it's not done. Now, when you do base 2, it takes a lot longer. I don't know how long this is going to be. You have to fill way down. All right, looks like it finished there. All right, so what we have here are not the decimal digits, but the binary digits. Of a number. Let's take a number that's easier, for example. Now we know, for instance, that 64 is 2 to the 6th power. So if I take 65, that should be 2 to the 6th plus 1. Let's take a look at the binary expansion of 65. All right, now here we have the 1's digit is 1, 2's digit is 0, 4's digit is 0, 8's digit, 16's digit, 32's digit, 64's digit. So my binary expression for 65 is 1, 0, 0, 0, 0, 0, 1. So you could do something larger, like 15770. Okay. In this case, let's see, my binary expression is going to be 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0. Okay. If I wanted to verify this, I can move over here and say power of 2. Okay. As I mentioned, this is the 1's digit, so I could put a 1 here. The next is the 2's digit, so I can do equals this one times 2. Then this one is going to be equals this one times 2, because that's the 4's digit. And I can fill that formula down by grabbing the corner. Let me fill it down to here. Okay. All right. Now, the binary expansion is going to be the binary digit times the power of 2, plus the binary digit here times the power of 2, plus the binary digit here times the power of 2. All right. So here I'm going to take the I'll do the factors, or I'll just call this expansion. Okay. So when I'm doing the binary expansion, I'm going to take the binary digit times the power of 2. Press enter. Let me fill this down to the bottom here. Let me also make my spreadsheet a little bit smaller so you can see how big it is. Okay, I think that gets me everything. And let me move it over to the here. And let's make this a little bit bigger. And this is power of 2. And then here I'll do the sum, and this is the check. All right. Now, if this is the correct expansion of the then if I sum these factors together, I should get the original result for my original number. So I'm going to take here equals, and I can take sum. That's the Excel way of doing a sum, and I'll take the sum of all these numbers. Okay. And I turn out with my original number. Now, because I've arranged my spreadsheet in a good way, I could take some different number here, and I get binary digits here. Notice you read from bottom to top, is largest to smallest. And when I check out my expansion, I still get 1999. Now, as I mentioned, the binary powers is an integral part of this method for computing numbers to large powers modulo a base. If you can see here in this spreadsheet, right here is the binary expansion portion. So these two columns are the binary expansion. So you'll build that into your spreadsheet for taking large powers of a number modulo a particular base. Now notice that even though the power is 3,000, over 3,000, the result has to be less than 617 because the base is 617, so the result has to be a number mod 617. Okay, so you'll make this spreadsheet and you'll create what you need to create. Okay, that's it for this one.